right. Good morning. My name is Gigi Richard. I'm the surface water hydrologist for the geology program here at Colorado Mesa University. During the breaks, I've had a lot of questions from people about Colorado Mesa, so I thought I'd share just a little bit about our little university here. 2 years ago, we were Mesa State College, changed our name 2 years ago. It's been a bit of a challenge for us, but I think it's a good thing. We're a small liberal arts college. We have a few graduate professional programs in nursing and business and teacher education. And we have a very somewhat small but very vibrant program, degrees in environmental science, geology, and we also have a watershed science minor program. And the students that have been involved in the project that I'll be talking about today are mostly in the geology, environmental science, and the watershed science minor program. As a small liberal arts college, our faculty tend to focus on teaching and not so much on research. So our research activities are involving undergraduate students often in our classes, and that's what this little project is about. It's my groundwater students working on a wetland restoration site along the Colorado River. It was a great opportunity to get students out and involved in a monitoring project, a real world project where they could get their hands dirty, a real hands-on project where they got an appreciation of also the complexity of interconnections in natural systems. It was interdisciplinary. Also, they've been exposed to hydrology, groundwater, geology, meet with engineers in the field, ecological restoration issues, and then also some policy implications as well. So just to orient you with where the site is, here we are, downtown Grand Junction, the Colorado River flowing to the northwest at this part of the valley. And here we are at Colorado Mesa University, and our little wetland site is over here adjacent to the river. It's a gravel pit that is owned by Mesa County. This is a photo of it just this spring in February. And so about 6 kilometers to the west of the university. So the site was mined by Mesa County for aggregate by the Road and Bridge Department from the 1950s through the 1980s. The property is about 10 acres, and it's within the 100-year floodplain of the Colorado River, and it's also within designated critical habitat of the 4 listed Colorado River species, fish species. The pond area in 2001 was about 4 acres, and the pond area does vary with our flood versus drought conditions. We watched the pond shrink as we progressed through the 2002 drought, and then have watched it grow again since the 2011 big high water year, and then watching it shrink again. They did survey the bathymetry of the pond in 2003, and the max depth was less than 1 meter. In 2004, the county initiated a study to determine suitability for use of this property as a wetland mitigation bank. And it was that point in time when I was contacted by the consultant I hired and said, hey, let's get some students involved in this monitoring project. So, you know, great opportunity to get students out and get their hands in the ground. You can see in this infrared image a lot of vegetation around the pond. This is almost all tamarisk around the pond. And so a major part of this attempt to develop a suitable wetland and get some nice vegetation going was to remove the tamarisk and then also to regrade the site. This white spot here is a large debris pile, very poorly sorted material ranging from silts all the way to cobbles that they redistributed and regraded throughout the site in the process of the restoration. So the goal was to develop a sustainable wetland that could be used for offsets for disturbed wetlands in other parts of the county as Mesa County does construction activities. The pond, the only inflows of the pond are precipitation and groundwater flow, and then occasionally if the river gets really high, there's a connection to the river. So in 2004, I got my groundwater students out. We met with a geology consultant here in town. You can see all the tamarisk on the site. And they hand dug and installed 3 piezometers, which is a little challenging in river cobbles. We managed to get them they vary from 4 to 6 feet in depth with about a 2-foot screen section at the bottom. Following the installation of these by hand by my students, the county actually went out and drilled and installed three more piezometers on the site. So For the following 7 years, then we had these network of 6 piezometers that my students could go out and monitor during my groundwater class. It was primarily during the spring semester when the class was taught, although occasionally we had interested students monitoring at other times. The questions that we were trying to get at are, what's the connectivity, the water table in this area with the river? What is the regional irrigation influence? The ditches get turned on in April and turned off October and November. Our irrigation season so spans from April to October. There's a lot of irrigated agriculture here in the Grand Valley. And then the other question is, what is the groundwater gradient across the site? Also, during the first 2 years of the monitoring, we also measured specific conductivity in the wells and all the surface water surrounding the site and that pond. So we'll look at a few aerial photos to see the changes that the site has undergone. You can see the locations here of the 3 piezometers that my students installed by hand, and then the 3 that were drilled by the county there. This aerial photo is from 2007. By this point, the county had begun mechanical tamarisk removal. So you can see the scars and the removal of the tamarisk in this north side of the pond here. And then they continued with their work in 2008 with more tamarisk removal. They started work on the regrading of the project. You can see they've removed the tamarisk here and here. And then by 2010, major regrading of the site. That big pile that was here is now redistributed around the pond. The tamarisk are gone. And then they went and planted wetland vegetation, which has had mixed success. They've had some problems because of the quality of the water, which I'll talk about in just a little bit. And also, apparently they had some issues with the ducks pulling all the shoots out. So they actually now have hired some geotech and environmental consultants to do a new design on the revegetation, which I'll talk about in just a bit. Then we had our exciting high flow year in 2011. And this is a photo, I think this was flown by U.S. Fish and Wildlife Service. There's a series of photos for the Upper Colorado, the Yampa, the green, and the white. And this was taken in June at about 45,000 CFS. So here's where our little pond would normally be, which is now a larger lake and actually connected to the river. Pretty exciting to see this happening. I also had a chance to see, I don't have a digital image of this, and I'd really like to get my hands on it though, but a printout of the aerial photo from the 1984 flood, which was the flood of record on the Colorado River in this reach. The state line gauge is a few miles downstream, the Colorado-Utah state line gauge, and at that gauge it's the flood of record just under 70,000 CFS. And so in 1984 they were actually building Redlands Parkway, so the bridge wasn't there, and the fill section of the road was there, and the road looks like a peninsula out into a massive lake. So we know that in 1984 this pond was also connected to the river. And by August 6, 2011, thanks to Google Earth, we can see that that connection is severed at this point, but the size of the pond is still a lot larger than it had been in the past. We can see things starting to green up. Unfortunately, some of that is tamarisk growing back again. And in 2012, as the county is thinking about, well, we need to, rework this restoration, it's not working. The wetlands not self-sustaining. They looked at some options for trying to get water in from other sources. And the Army Corps of Engineers really wants the site to be self-sustaining, and so they need to figure out at what level they need to regrade things to have a sustainable water level. And so they installed 10 new piezometers, and they're continuing with this plan for restoration. And for the next year, they're going to be doing some really intensive monitoring of what's going on with the site. And here's some of their new piezometers, and then this was one of the ones that was drilled in by the county in 2004. All right, so our results from my student monitoring, this has been over a period of 8 years, starting in 2004 through 2012. And again, like I said, most of the data points were only taken in the spring, so there are some limitations, there's some challenges working with undergraduates. The semester ends in May. the peak flow of the river is usually later than that, so we don't necessarily catch that. I think that there's now enough interest in this site that I'm probably going to get some more students interested in doing some research projects on it, so I'm excited about that. So first, let's look at water level in the pond and piezometer number 1. And all of the graphs I'll show you, we've got time on the x-axis going from 2004 through the end of 2012, and then our water elevation in feet. And we can see piezometer number 1 in the pond really don't respond. Oh, let me end the next. This is the hydrograph at the Colorado River at the state line on the same time axis. So we can see 2004 was a pretty low flow year, 2007 was low, and then we can see our lovely drought year of 2012 here, and our big peak of 2011, which was about 47,000, I think. CFS was the peak there. Coming into this period, we had a multi-year drought period, with 2002 being a very low flow year. But what we see with the pond and this piezometer that's on away from the riverside of the pond is that they're pretty slow to respond to the change in hydrology, change in the runoff in the river. And if we move to piezometers 2 and 3 on the riverside, so here's the river right here, we can see a little bit quicker response as the flow in the river starts to come up. We start to see changes in the water level in the piezometer. So we definitely have some connectivity here with the river. And then if we jump over to piezometers 4, 5, and 6, so 4 is in blue here, which is the blue line here. 5 is orange, the orange line here, and then 6 is the closest to the river. We can see at this point in 2006 that we actually had a change in direction of groundwater, where we're going to have groundwater flowing from piezometer 6 more towards the pond, whereas a lot of times of the year the groundwater flow is towards the river. So in 2006 we actually had a shift in direction. Unfortunately, we changed our teaching schedule so that I only teach groundwater every other year now, and so you can see there's a gap in here. We taught groundwater in 2008 and then in 2010, so I don't have any data in 2009, or in, unfortunately, 2011, which was kind of a big failing on my part also, that I didn't just get out there and monitor it on my own in the midst of the flood. But all right. So another thing that we did in those first 2 years, like I said, is to measure water quality. All we looked at was specific conductivity. There's a lot of question about the salt content and maybe possibly the selenium content of this pond. And so the first time we went out, we went out a couple times in April of 2004 and measured the specific conductivity in the river, in this gravel pit, and in this irrigation ditch here. This is a ditch. In this gravel pit, in this gravel pit, and then in our pond. And I'll start with the lowest. The irrigation ditch here and the river are both about 700 microsiemens per centimeter. These are our averages. The variability was really low, so I didn't include error bars on this. This pond, 3,400. This one, 6,000, almost 14,000. And then our pond, 27,000. So this potentially could be part of the contribution to some of the challenges they've had establishing vegetation in the pond. I know this has helped them think more about finding salt-tolerant species. And then looking at the specific conductivity in the groundwater, this is the average values from April of 2005. Closer to the river, our lowest conductivity. And then as we move away from the river and have more influence from this pond and potentially irrigation return water, and then this piezometer here, which actually this one now with all the regrading is gone. At one point it was in the pond and now it's disappeared. So 21,000 microsiemens per centimeter. So that's pretty close to what we find in the pond. So ongoing work, I did have a student in my GPS class, and also she's doing an honors thesis on this site. So she did some mapping of the vegetation. This is after their tamarisk removal and replanting. So she did this monitoring in October, November of 2012. And red identifies where there's tamarisk. They did not remove the tamarisk on the south side of the pond. But all of the tamarisk that you see up here is regrowth since their removal effort. And the beige is kochia, so, and other invasive weeds. And then you can see the green is the wetland vegetation. And she has a poster out there if you're interested in having a look at that. She also did some water quality monitoring and pretty much came up with similar values for conductivity. She looked at pH and DO as well. So the county is continuing to monitor, my students will continue to monitor, and the county is going to keep working towards their wetland mitigation banking project. And just in summary, one of the things I learned from this is the value of collaborating with local governments and continued monitoring, even if it is on kind of a small teaching scale project. It's been a great opportunity for my students to, meet with professionals in the field, meeting with county engineers and, geology consultants, environmental consultants. They've learned a lot of things. One of the things I have them do is potentiometric surface mapping. They learn a lot of field skills also, and I think most importantly, since it's a real problem, it's a great opportunity for students to see things that aren't so simple, that there really are complex interactions in the real world. And in natural systems, it's not a clear, perfect solution like a lot of textbook solutions. And that's it. Thank you.